So, warmly welcome. I want to take the opportunity to thank all of you for taking time to join us here today for this session. This session is entitled Building Your Network Architecture for VMware Cloud on AWS. My name is Schneider Labi. I'm one of the senior partner solutions architects here at AWS. I've been working here for about 2.5 years, and I specialize around VMware Cloud on AWS. I work with the core engineering teams in delivering new features and designing new services around VMware Cloud on AWS. I also specialize around hybrid edge services in AWS, which includes AWS Outposts, which enables our customers to run the AWS cloud in their data centers. So that's a little bit about me, and it's good to have all of you here, as I've said. And today, the learning objective for this workshop is to help all of you to understand everything networking when it comes to VMware Cloud on AWS. And we would also talk about how to implement hybrid network architectures when it comes to using this service. We would also go through how to do this hybrid connectivity with AWS Direct Connect. And then we will talk through how to build a global connectivity model for hybrid connections using VMware Transit Connect. And then we will share some useful links with you as well. One thing I want you to know is that feel free to ask questions in the chat rooms. We have moderators, and we will do well to respond to your questions whilst I do this presentation. So that being said, also you can download the lab guide that Eric spoke about. You can follow this along, or perhaps you can use it later on, either in your test environment before you transition into production to test these features that we're going to discuss today. So let us get to it. Let us have a quick recap about what VMware Cloud on AWS is before we even go ahead and talk about how we do networking on top of it. So what is it? What is VMware Cloud on AWS? As its name suggests, this service is a service that was jointly engineered by VMware and AWS to allow customers who run VMware on premises today to run their vSphere workloads on the global AWS infrastructure. So VMware Cloud on AWS is powered by the VMware Cloud Foundation. We use vSphere as the hypervisor. We use vSAN as the software-defined storage and NSX as the software-defined networking. And we use vCenter for its management. Everything is the same, just like you know on premises, the console, everything is the same. Once deployed on this global AWS infrastructure, customers or partners can then start consuming it by extending the boundaries of their data centers into the cloud and start migrating to it. That is what VMware Cloud on AWS is. Additionally, all applications that customers use on premises that is supported by VMware also runs seamlessly on VMware Cloud on AWS. If customers are using tools such as vRealize Suite or other third-party vendor tools that are supported on VMware, we give you the operational consistency of running both applications in both environments. But one beauty of this VMware Cloud on AWS solution is that we also give you the opportunity to tap into the native AWS services. What that means is that you can complement your applications on the vSphere platform with native AWS services. For instance, you can choose to offload your object storage from your virtual machines to AWS native storage such as Amazon Storage Service, which Simple Storage Service, which we call the S3, or you can choose to use managed databases such as relational database management services in AWS with your VMware workloads. And we give you connectivity to allow you to do all of this. So at a high level, this is what the service VMware Cloud on AWS is about. But now here is the interesting part. to be able to migrate to this platform from on-premises or to be able to make use of it in any way, there has to be some form of connectivity, right? Without network connectivity, there is no way you can access those platforms. There is no way you can migrate your applications. We are going to have other workshops in the coming days around migration, disaster recovery, among other things. And the foundation for that is network connectivity. So to go into the network connectivity, I would like to start from scratch to give you some basics on how we have architected this VMware Cloud on AWS on the global infrastructure that we have. Now, if you've been working or if you've read a bit of AWS, we do have an AWS region. And in that region, VMware works with us and they have an account in that region. And this account is a normal AWS account. And within this account, they deploy a construct that we call the Virtual Private Cloud, or we will call it a VPC for short. If you've worked a little bit with AWS, you know what a VPC is. It's a segregated section of the cloud just for you, the customer, so that no one else sees what you're doing in the cloud. It's your own area of the cloud to put your applications. So what we do with a VPC is that within this VPC, we deploy the bare metal instances into it. On premises, you're using bare metal instances like HP or Dell hardware. We are also using bare metal instances called EC2, and that is what we install the vSphere onto it. Then the VPC, as you see here, provides uplink connectivity to these EC2 instances you see here. Then on top of that, we put the software-defined networking, which is the NSX. Now, this NSX can be broken into two segments. We have the management segment and we have the compute segment. The management segment for the NSX is the segment of the NSX network that runs the vCenter, the NSX Edge, and the management components for your VMware Cloud on AWS environment, or the SDDC, which stands for Software Defined Data Center, right? The compute network is not just one single network. It's a collection of all the logical networks or subnets that you would create and connect to your virtual machines. Each of these network subsegments, they all sit behind gateways. The management sits behind this management gateway, and the compute segments, that is all the subnets you create to connect to your virtual machines, sit behind this compute gateway. These are all virtual appliances that are running in the global AWS infrastructure to power your software-defined data center. These two appliances you see here, or gateways, also terminate on what we call the NSX Edge. And the NSX Edge acts as a router to allow you to send traffic outside of this SDDC to wherever you want to send the traffic, being it to the public internet or towards on-premises. Now, how do you get to the public internet? If you've worked with Amazon VPC or the Virtual Private Cloud before, these VPCs have a construct that we call the Internet Gateway. So think of it as some form of a path that allows you to send traffic outside of a VPC. So this NSX Edge has a path to this Internet Gateway, and that is how we send traffic outside the software-defined data center we build on the AWS infrastructure to anywhere on the internet. So what you can see here is that this VPC becomes the underlay network or the foundation network for a software-defined data center, and then the NSX becomes the overlay network on top of that. But this discussion is about hybrid connectivity, right? So how do we even send traffic to your on-premises environment? Every VPC has two constructs that makes this happen. One is what we call the Virtual Private Gateway, and the other is what we call the VMware Transit Connect. And we will go into details what these constructs are in our discussion. But then you remember that I told you that when you set up an SDDC in the cloud, we give you the opportunity to use our native services. So how do we do that? Think of your SDDC as the one to the left. That one lives in an AWS account that is managed by VMware. So before you deploy an SDDC, we ask you, the customer, to also have an AWS account, and that account should have a virtual private cloud and a subnet in it. And so we ask you to connect your AWS account to your software-defined data center. When you do that, we create what we call cross-account elastic network interfaces between the bare metal instances and your virtual private cloud. And so whatever network you create on the SDDC side, your VPC knows about it. We automatically update the routes tables in your VPCs. This would allow you then to continue to use our native services. So this is how we do this in the cloud. But what about going to on-premises from the cloud, as this discussion is about? That is what introduces us to hybrid cloud network architectures. Now, what really is hybrid cloud networking? VMware themselves defined it as a network that enables data transfer between on-premises IT resources, private clouds, and public clouds. That is what hybrid networking is about. Now, how are customers and partners today doing this from on-premises to VMware Cloud on AWS? Now, customers are using VPN. Some customers are using VPN, which is virtual private networks, to do this connectivity. But VPNs have their limitations and they have the issues they come with. And that is why in this session, we are going to go through how you can use AWS Direct Connect to do this hybrid network connectivity to allow you to design a robust network architecture for VMware Cloud on AWS in a hybrid model. So what is Direct Connect? Direct Connect is an AWS service that enables our customers to have low latency, secure, and private connections to AWS workloads. This is mostly for services or applications that require higher speed or lower latency than the normal internet. So a simple way to think about this is that think about the internet as a highway, and the cars you see on it, think of it as your network traffic. Now, if you see this highway to the left, it is actually going to take you time to get to where you want to go to, right? It can be unpredictable. There could be crash on the highway that can increase traffic and that can impact wherever you want to get to and the time it takes. The same applies to networking if you're going through the public internet. What Direct Connect does for you is that we give you a dedicated path, a highway of your own that you can use to send your network traffic to the AWS region. So like you can see to the right, if you have your own highway, you get to wherever you want to go very quickly. One thing I like to highlight here is that if you are familiar with Direct Connect, there is something we call hosted connections. Now, hosted connection is a connection that an MSP might have and share that connection with so many customers. If you use a hosted connection, you can easily run into the situation you see in the left picture because there are many customers running on that. So when you want to use Direct Connect with VMware Cloud on AWS, we highly recommend that you go for a dedicated connection. That connection is for you only, not shared with other customers, and that will give you the path from your on-premises to the AWS region. So Direct Connect is a physical connection that we do. And on top of that physical connections, we create what we call virtual interfaces. These virtual interfaces connect between your on-premises device and to the virtual devices we have on VMware Cloud on AWS. The supported types of virtual interfaces for Direct Connect today is what we call public virtual interface. This interface type is only used when you want to do routing using public IP ranges to the AWS region. And then we also have private virtual interface, which we call the private VIF for short. And we have the transit virtual interface, which we call the transit VIF for short. I should write transit VIF over there. So now in this discussion, we are going to highlight the two major interface types, the one highlighted in yellow, private and transit. That is what we'll be talking about. We'll be showing you how to deploy it, how to configure it, because these are the most widely used interface types available on VMware Cloud on AWS today. What then are the benefits of using Direct Connect to you as a customer or a partner? One, you would get low latency connectivity to VMware Cloud on AWS, depending on the Direct Connect location you use. You can also have a high bandwidth to VMware Cloud on AWS based on the connection option that you purchase for your Direct Connect circuit. You can also have the ability to do hybrid vMotion. Right, today, for customers who run VMware on premises, you do vMotion from host to host between your clusters or within your clusters. But this Direct Connect will give you the ability to do a vMotion from your on-premises to the cloud in a live fashion. This Direct Connect helps you to fulfill the latency requirements for that. You also have the ability to unlock all the scalable networking features on VMware Cloud on AWS if you use Direct Connect, just like we are shortly going to demonstrate to you. Then finally, you can have a secure private connectivity to VMware Cloud on AWS. So these are some benefits to you as customers and partners if you decide to make the decision to use AWS Direct Connect to connect your environment in a hybrid model to VMware Cloud on AWS. So how does the Direct Connect itself even work? So let's look at this diagram here. We have VMware Cloud on AWS to the left side. You have your on-premises side to the right. What we have done is that we have worked with partners. And when I say we, I mean AWS have worked with partners such as data center operators and MSPs to create what we call the Direct Connect locations. You can find these locations all around the regions where we operate. And in each of these Direct Connect locations, there is an AWS rack that has the Direct Connect routers. These connect through high-speed fibers back to our region. So if a customer wants Direct Connect, what happens is that in most cases, the customer would have a cage in the same Direct Connect location with a connectivity back to their office or wherever they want. Then what we do is that we create a cross connect between their cage and our AWS cage, and we give them a port on our Direct Connect router. That becomes their dedicated path between their on-premises to VMware Cloud on AWS. So this is how Direct Connect works. Now, this is just a sample architecture here. The customer doesn't have to have a cage in the same Direct Connect location. We can work with our partners, or you can work with the partners to have a last mile connectivity from their location directly to your office or to your data center or wherever you want that traffic to go. That is also supported. So now, like I said, we've seen how we do Direct Connect at the physical layer. We are now going to talk about how we configure these private virtual interfaces to use them. So the first interface type, as I mentioned, I'm not going to talk much about the public. That is not used too much on VMware Cloud on AWS, but I'm going to focus on the private virtual interface. So this interface type connects between your on-premises device, and it terminates on what we call the virtual private gateway at the AWS side, or the VGW. And once configured, we use Border Gateway Protocol to exchange routes between these two devices you see here. And that is what enables you to start having connectivity between your on-premises and VMware Cloud on AWS. So here is how that architecture looks like. If you have the physical connection done for your Direct Connect, then we create this private virtual interface and terminate it on the virtual private gateway or the VGW. And then what happens is that the NSX edge you see there extracts the routes that we advertise over this private virtual interface. And then your virtual machines and the logical networks you've created would also go over this same link towards your on-premises devices. And this allows you, it sets the foundation for you to migrate or do vMotion and do whatever you want to do from connectivity standpoint. Now, when you use private virtual interfaces, this interface type can scale. When I say scale, if you have multiple SDDCs, you can still configure multiple private virtual interfaces over your single direct connect connection into each of these SDDCs. Now, if you have a single direct connect connection, you can have up to 50 virtual interfaces on it. This 50 could either be a private or a public virtual interface. And in addition to that, you can have only one transit virtual interface. You can have more than that, right? So you have to factor that in when you are architecting your environment. But when we talk about the transit virtual interface, I'll show you how that works. So this is how you can scale private virtual interfaces as well. So how do we actually configure this? I did mention that we do this between your on-premises device to the VGW or the virtual private gateway. So I'm going to show you a sample configuration. Now, I just did this from a Cisco device. Now, the device commands and interfaces might look very different if you're using a Juniper or a Palo Alto device, among other things, but the principle is essentially the same, right? From a Cisco device, as an example, you would have an interface that connects the physical direct connect fiber that you have, the cross connect I spoke about, right? And what you do is that you have to create a sub interface, and usually we match it with the VLAN ID for this specific interface type. And then you give it a description, right? Like I have given here. And then you explain the VLAN tagging, you give it the VLAN association here, where you can see that here I selected this 333 as my VLAN ID. Then the next thing to do is to have your /30 BGP peering IP address. And then once you have that, you're ready to now configure BGP. If you're configuring the BGP, you need to also know the autonomous system number for your networking device that would be used for the BGP route exchange. So you specify that ASN, and now you need to also have the remote BGP ASN number, which you can see that I've also specified that in there. So then you also get your peering IP for the other side, the termination point at the AWS side, and also have your authentication key available. Then the next thing to do now is that you now want to specify which networks you want to advertise over this private virtual interface towards VMware Cloud on AWS. And here you can see I'm advertising a number of subnets I have on premises. So one thing I want to highlight here, if you want to do hybrid vMotion, which is vMotion between your on-premises to VMware Cloud on AWS, you need to remember to advertise your ESX management network on premises over this private virtual interface. Otherwise, the vMotion is going to fail. And you can advertise any other network you want your SDDCs in the cloud to communicate to. Then you just close up the configuration and run it, and you should be ready to go, right? Now, there are cases whereby maybe you don't even have your peering IPs. If you don't have your own peering IPs, if you create a direct connect private virtual interface, we go ahead and generate one for you. And we are going to see how we do this in the lab. So enough of the talk. We're going to go in the lab to show you a few things. But one thing I want to highlight at this point is that configuring some of these things can take some time to happen. For example, if we are advertising the BGP, it could take minutes. And so to be respectful of everyone's time, what we have done here is that we have recorded these lab sessions and we've taken out all the waiting time so that you can follow along with the guide that you downloaded. So let's go into the lab and let's follow through how to create a private virtual interface and use it, and then we'll come back to our discussion. So welcome into the lab. And in this first demo that we're going to do, we would configure connectivity between VMware Cloud on AWS, software-defined data center in the cloud, specifically in US East 1 region. And we would link that to our on-premises environment in Virginia around the East Coast. So in this configuration, we're going to use AWS Direct Connect, and we would use the private virtual interface to do this connectivity. Now, it is assumed that you have already configured your BGP peering configurations using the peering IPs, the VLAN ID, and the prerequisites explained in the previous slide in your on-premises device. So after you have done all those things, then you have to now go into your SDDC console and the AWS Management Console to do the configuration. One thing I would like to highlight for those of you following the guidelines that you've downloaded, you can see that we have these set of IPs for my on-premises environment. The 172.20 is management, and the 172.20.11 is for vMotion, and the ones in the 10.3 ranges are compute for my on-premises environment. In my software-defined data center in the AWS region, I've created one SDDC called demo SDDC, and in the management subnet for that one, I'm using 10.7.100.0/23, like you can see on the screen, and then I have 10.7.107.0/24. But to even show you more, let's go to the vCenter on premises. This is my on premises vCenter, and this is my on-prem virtual machine. That is 10.3.10.2. That's the IP. And then if we go to the SDDC, this is my SDDC virtual machine, and the IP is 10.7.107.2. So I just want to test connectivity. Let's try to ping this virtual machine in the cloud, which is 10.7.102.2. So let's go and let me verify. It's actually 107.2. Yes. So 107.2. If we try to ping this, you can see that we are not able to ping. And the reason is that there is no connectivity between my on-premises environment to VMware Cloud on AWS. But now we are going to enable that connectivity, and these two virtual machines should be able to talk to one another. And that is what Direct Connect is going to do for us. So before we start, let me take you to the SDDC console. Let's start from there. So you log into the SDDC console and you provide your credentials. And after you log in, you would see that you have subscribed to VMware Cloud on AWS. So I have a number of SDDCs here for test purposes, but now you can see that I'm in the right organization that I've set up for this webinar. So you can see that here I have VMware Cloud on AWS. If you are already subscribed to the service, this should be there, and you should click on that. Once you click on it, it will show you the software-defined data centers or SDDCs that you have deployed within this specific organization. So here I have this demo SDDC1 in US East, and that's what we'll be using for this part of the demo. So it tells you we are connected to US East 1A, so we can log in and you can see the compute capacity that I have here and my storage capacity as well. But what we are interested in is to select networking and security. And then you have to then select the Direct Connect tab below. So here you can see that we do not have any Direct Connect private virtual interface configured here. There is nothing here. But like I explained initially, we built this SDDC into an AWS account with an underlying virtual private cloud or a VPC. And so we need this AWS account. We need to copy this account number because we would need that when we are creating our virtual private interface. Because one thing we are doing is that we are creating that virtual private interface in our own AWS account, and we will share it with this account so that it can allow the connectivity. So now that we have this account ID, let's go to our AWS Management Console, and I can apply my credentials here. and then we can log in. And when you log in, these are the recent services that I have used. But if you want to go to Direct Connect, you can search it. Just type in Direct Connect and that will pop up. And if you select it, this is how it looks like. So if you click on connections, if you have subscribed for a direct connect circuit, after the circuit is provisioned, it will populate itself here and you can see the details. So here, this is my direct connect connection. I have a 10 Gbps pipe from my on-premises through a direct connect location to the AWS region in US East. If I go further into the connection, you can see some details about it. You can see the region where it's going to. You can also see when I ordered for this thing here. You can see the device it connects to. You can see the direct connect location that I'm using. I also have jumbo frames. You can see all that information here. But what we want is the virtual interfaces. So select that. And again, here you can see a number of virtual interfaces that I have created here. We are now going to create a new one. So you select create virtual interface. The type of virtual interface we are creating now is the private virtual interface. So we would give our private virtual interface a name so that we would be able to identify it. So let's just give it webinar demo private virtual interface. Now, if you do have more than one direct connect circuit or connections for redundancy purposes, you will be able to select the direct connect circuit that you want to configure this private virtual interface on. So you do that from this drop down menu and we select this. And like I said, we are not creating this private virtual interface to use by ourselves, but we are rather sharing it with another AWS account that is holding our software defined data center. So here you have to select another AWS account. And this is where you need to put the ID for that account. And that is why we went to the SDDC console to copy this account number. Now that we have this, we can click the VLAN and put the VLAN ID. So I have already pre-configured this VLAN ID as a sub interface on my on-premises device. So use that same ID here. And now I need to provide the BGP ASN number for my virtual, not virtual, but for my physical device or network device on premises. So at this very point, if you don't have your own BGP peering IPs for pre-configuration already on the on-premises switches like I have done, you can then click Create Virtual Interface. And when you create it, it will go ahead and provide you with the details you need. It will provide you with the peering IPs and the BGP authentication ID you need to configure the BGP at the other side, which is on your on-premises device. So let's just click create and I'll show you what happens. When you create, it goes to a confirming state. And what is happening is that we've sent a request to the account that is holding your software defined data center to share this interface with it. So let's go back to our SDDC, network and security, and direct connect. If we refresh this page, it should pop up here. So now you can see that our virtual private interface, the same name as we have on the AWS console here, it is showing itself here now. So what we have to do is to attach it to the virtual private gateway of the underlying VPC to allow the connectivity. So you say you understand that you would incur data transfer charges and then save. The very moment you do this, you would get the peering IPs generated for you automatically. So if you come to the AWS console, locate the private virtual interface and then click on it. So from here, you can see the details. You can see the ID for the virtual private gateway we've connected to it. And at this point, the BGP session will be down because you do not have this peering IPs configured on your router, right? So you can go to actions and say sample configurations. And depending on the device you have on premises, being it Cisco, Juniper, or Palo Alto, you can download the configurations that you need to do. So let me quickly glance through how this thing looks like. So when it comes here, you can see that it's helping you to create your sub interface. If you're using port channels, it's telling you how to configure it all and your peering IPs. So if you are not into networking, you can let your network engineer do this. They do understand this very well. Here is the BGP configurations and also the networks that you want to advertise from on premises. Of course, you would have to modify this to suit what you have on premises. So this is how it works. If you do not have your own BGP peering IPs like I have, and then after you have configured that on your device, the BGP session will start initiating and the BGP status will come up. But this is how it's done. But in the case where I have done the pre-configuration, I'm going to go back to show you how that also works. So back to where we set off, this is the case where I have my own BGP peering configuration. So I'll just go here and say additional settings. And then here I'm going to put my router peer IP, which I have already pre-configured on my on-premises device. I'll put that here, and then I would select another one. This will be the Amazon router peer IP. I'll select that, and then I'll also put that here. And then the last thing is going to be my BGP authentication key, which is here. I'll also pick that and I'll put it here. And because I have jumbo frames enabled, I'll select that as well. And this is how it is. If I have my own peering information, this is how you do it, right? So now I have it all there. Then I'll say create virtual interface, and it will go into the confirming phase again. And then I have to come to the SDDC console and then refresh. And once this is refreshed, we are going to attach this to the SDDC. And specifically, we are attaching this to the SDDC through the virtual private gateway of the underlying VPC. So you say you understand and then you say save. So this will get into a process whereby you can see that it is attaching. After the attaching, it will change to attached, which means that it will be attached to the SDDC console, or I should say the NSX edge within the SDDC. Once that attachment is done, the NSX edge will start pulling the routes from the virtual private gateway, and you will start seeing the routes that we are learning from on-premises here. And you would also see that we would begin to advertise the networks we've created on this SDDC towards on-premises. Let's quickly go here to network segments, and I'll show you the networks that I've created. So this is my cloud network, right? When the BGP session initiates, it would advertise this network together with the management network of this SDDC towards on-premises. And that can take anywhere between 5 to 10 minutes for the BGP session to come up. It's all based on the number of networks you are advertising, the distance, how fast your devices are, how busy the network is, among other things. So you can also keep refreshing because the UI also takes some time for the configurations to complete. So at this point, you can see that it's been successfully attached, and we are already advertising our networks that is on the cloud side, plus our management ranges in the SDDC towards on-premises over the BGP session. Now, what is going to happen is that we are initiating the handshake from on-premises, and once the BGP is enabled, or let me say authenticated, what is going to happen is that you will start seeing that we are learning the routes from on-premises. You will see the learned routes being populated here. So all those networks that I showed you on the screen from on-premises will be advertised here. And that means that we are now ready to start communicating between on-premises and VMware Cloud on AWS using Direct Connect private virtual interface. When the configuration is entirely complete, you would see that this BGP status would change from down to up. Everything would be green. But even if you refresh, you can see that we are already starting to learn the routes from on-premises already, which is a good sign. That means our configuration is working. You can see that the routes are being populated here. And then the next thing is that this status is going to change to up. If we go to AWS Management Console, this is our private virtual interface here. So when we select it, you can still see that the BGP state is down and this peering is still down. But once the session is fully initiated and all the configuration checks are done, this status should also change to up, just like we expect it to be from the SDDC console. As this is happening, one quick thing I'd like to show you is that you would obviously need to allow the firewall on the SDDC side to allow traffic from your on-premises to VMware Cloud on AWS. The way to do that is to quickly go to the gateway firewall, and on your compute gateway, you can see that I've created inbound rules for my on-premises networks, and then I have my outbound rules as well. And usually when you create these rules and apply them on the Direct Connect interface, right? That is what uses the Direct Connect path. So let's go back to our Direct Connect tab and let's see if it's done. So at this point, we just have to wait for this status to say up. And then you would see that everything will be working. So at this point, if we go to our on-prem VM, which is this test on-site VM, we will try to ping the cloud side again. And let's see whether we have connectivity. You can see that it's still not going to tell us anything until it says that this status is up. That means that everything is up and ready to go. So at this point, we just have to wait for it to say up, and then we can continue to run our ping test. So now you can see that our BGP status is now up. You can see that we are also advertising traffic from on-premises to the cloud and vice versa. Everything looks good here. If we come to our AWS console, you can see that our BGP status is also up and life is good. So now let's test if this configuration really works. Let's go to our virtual machine and let's try to initiate another ping again. So you can now see that the ping is starting to work right now. We are receiving ping responses from our on-premises test virtual machine towards VMware Cloud on AWS in the region. Let's go to our VM in the region, and oh yes, you can see that I already initiated a ping and that is also responding, and there is a connectivity between on-premises and VMware Cloud on AWS. One thing I wanted to show you though is that take note of these latency numbers here. You can see the latency numbers is below 2 milliseconds over Direct Connect between on-premises and the SDDC. What I've done is that you can also allocate an external elastic public IP to virtual machines in the cloud. So I did that so that we can ping that public IP towards this virtual machine. And that is not going to use the direct connect path because it's a public IP, is going to use the internet gateway path over the public internet. And when we do that, we are going to see the latency numbers. We're going to compare the latency numbers. So let's try that. So if we say ping that public IP is 54.197.134.93. So again, quickly to show you, if you want to do that, you can come to the SDDC console and go to NATen. And then here in the NATen part is where you can assign a public IP, right? So if you come here to public IPs, you can first request a new IP, and once the IP is allocated, you can go to NATen and NAT it to a virtual machine. And that doesn't use the direct connect path. It uses a different path through the internet gateway of the underlying VPC. So let's ping this public IP. And now you can see that our latency numbers are now higher, right? It's 2 point something, sometimes even 3. As you can see, it differs from using Direct Connect. So you can see the benefit of using Direct Connect here. It allows you to have lower latency depending on where you are located to the AWS region as opposed to using the public internet. And this is best scenario when there's traffic saturation, the latency numbers over public internet can be high and it's not predictable. So from here, you can see the benefits of using Direct Connect and connecting that between your on-premises and to your vSphere workloads on VMware Cloud on AWS. So, congratulations, you've successfully configured a private virtual interface over Direct Connect. So, the architecture you can see right now on your screen is what you have architected. And as you can see, it's actually simple and straightforward. And if you have difficulty in doing this, that's why we are here for you. Reach out to AWS, reach out to us. We are always happy to support you to architect your environment to support VMware Cloud on AWS and your connectivity strategies that you choose to implement. So this brings an end to this specific demo about configuring private virtual interface. We are now going to go ahead and talk about a new type of interface that is supported by Direct Connect. So welcome back from the lab. So that was how to configure a private virtual interface, and you've seen how straightforward it is and how it works. Now we're going to talk about the transit virtual interface. So what is different about the transit virtual interface? We learned that the private virtual interface terminates on a virtual private gateway. The transit virtual interface, on the other hand, is configured a little bit differently. That one terminates on what we call Direct Connect gateway, as opposed to the virtual private gateway. And how it works is that after you associate it or attach it to a Direct Connect gateway, then you have some capabilities and options here. You can either associate a VMware Transit Connect to the Direct Connect gateway, or you can associate a virtual private gateway to the Direct Connect gateway. A lot of gateways, right? So you can't associate both at the same time. You have to use one. But when it comes to VMware Cloud on AWS, the only gateway or the only thing or the only network construct that you can associate to Direct Connect gateway will be the VMware Transit Connect. So what is VMware Transit Connect? VMware Transit Connect is nothing other than an AWS Transit gateway that is managed by VMware. It allows you to have a hub and spoke routing capabilities in the cloud to other destinations as well as even to on-premises as well. And that works with Transit Virtual Interface. That allows you to implement some scalable architectures we are going to talk about. As you can see from that screen here, if you want to connect to multiple SDDCs, this is when you need a transit virtual interface. And a transit virtual interface can do the job. So how do we pull it off? How do we do that? We introduce something we call SDDC grouping. The concept of SDDC grouping allows you to group SDDCs together, attach them to a VMware Transit Connect, and route traffic between them. So when you create an SDDC group from the SDDC console, what happens is that we create a Transit Connect in the background. And then we attach this SDDC or this VMware Cloud on AWS environment to that Transit Connect. And that is how we are able to get it to work. And then what that means is that subsequently, if you keep adding any SDDC into that SDDC group, those SDDCs or VMware Cloud on AWS clusters will all be attached to the same Transit Connect. And it allows you to route traffic between each of these SDDCs in a seamless and scalable manner. So this is one simple way for scaling your networks. And this happens within the same region. You have to be in the same region to do this because the Transit Connect is a regional construct. But now we are talking about hybrid connectivity between on-premises and the cloud. So how do we get all the networks or routes in all these SDDCs within a group to get to on-premises? Transit virtual interface allows us to do that. So what you have to do at this point from this architecture is to associate that VMware Transit Connect you see there to the Direct Connect gateway. Once that association is complete, all the routes in that SDDC will travel through the Transit Virtual Interface towards your on-premises environment. And you can send traffic in a scalable and in a simplified manner to multiple SDDCs. Now, what if you have a situation, right, where you have two different regions? Let's say you have VMware Cloud on AWS in US East 1 in America, and you also have another SDDC in the EU region in London, right? You want to use your existing Direct Connect and a Transit virtual interface to reach them. How do we do that? Well, we use the same concept, right? I spoke about the SDDC grouping. If you have an SDDC group, it initially creates a VMware Transit Connect and attaches an SDDC to it. But now we have given you the capability to also include SDDCs in other regions into the SDDC group, thereby extending the boundaries of the original SDDC group created. And when you initiate that process, this is what we do in the background. We create a second VMware Transit Connect in that target region. We attach the SDDC in the target region to that Transit Connect, and then we create an inter-region peering connection between the two Transit Connects, the one in the source site and the one in the target site. And that is how we allow you to route traffic regionally and in a global manner. So think about it. You can have one Direct Connect location in the US and route traffic to Australia, route traffic to Asia, route traffic to Europe, and wherever you want on VMware Cloud on AWS. Now, what about sending the traffic back on premises? All you need to do is to associate these transit connects you see here to the Direct Connect gateway, and then all the routes will go over the transit virtual interface towards your on-premises environment. At this point, one design consideration that I'd like to highlight here is that you can only attach up to 3 transit connects to a Direct Connect gateway. So one Direct Connect gateway can only handle 3 Transit Connect attachments. If you need anything more, you have to deploy a second Direct Connect gateway. And so that is how the architecture looks like, and that is how it works. So this is how we allow you to do interregional connectivity and also have a global hybrid network architecture when it comes to VMware Cloud on AWS with the help of Transit Virtual Interface and VMware Transit Connect. So at this point, I'm going to go back in the lab again to show you how to do this. Again, like I mentioned, to do these configurations, they can take a lot of time. So we recorded it and then took the waiting times out of it, consolidated it for your consumption within the time limit we have. So let us go back into the lab and let's talk about the Transit Virtual Interface. So welcome back to the lab. Here in this demonstration, we are going to see how to use the Transit Virtual Interface with SDDC grouping and VMware Transit Connect to configure inter SDDC network connectivity as well as connectivity back to our on-premises environment. So in this demo, I'm not going to spend time to show you how to create the virtual interface. The process is the same as we do for the private virtual interface, and you can download the guide and follow through with the captures I have in there to show you how to create it. Once it's created, we will come to our AWS Management Console, and this is how it looks like. You can see that this Transit Virtual Interface is associated with this Direct Connect gateway. And you can also see from here that our BGP peering is also up and everything looks good here. But what we care about most right, is the Direct Connect gateway. So if we click on the Direct Connect gateway and select gateway associations, we do know that when we create the SDDC groups, the SDDCs attached to the Transit Connect will be able to communicate, but they won't be able to go to on-premises until we associate the Transit Connect to this Transit Virtual Interface. That is how we are going to get it to get the route from the Transit Virtual Interface. So let's go ahead and start creating our SDDC groups. And here you can go to the SDDC group tab from the SDDC console and click Create Group. And we can give it a name like Webinar SDDC Group. And in this demo, we are putting SDDCs within the same region into this group. So this is SDDC1 and SDDC2. These are all in US East regions. We are putting these into the SDDC group. So let's go ahead and click on next. And then we are told that when we do this operation, it is going to create a VMware Transit Connect and we would incur attachment charges. So at this point, we would say create SDDC group and then the operation begins. Now this operation can take anywhere between 8 to 10 minutes before it starts working, in some cases even longer. So once this is running, we can go into the SDDC group and you can see that this thing here, the status here will say pending. What we are looking for is for this to change to connected. That means that we have attached these SDDCs to the Transit Connects that get created in the background. We would wait for that to happen. Now you can see that we have it connected. That means that the Transit Connect has been created and we have attached our SDDCs to it in US East region. Click on the support tab to confirm this. You can see the ID for the transit gateway here. For support purposes, you can come here and check it. At this point, there is this feature called vCenter linking, which allows you to have linked mode for all vCenters that are within an SDDC group. It's actually useful to do that because you can maintain and manage all the vCenters for your SDDCs within a group from a single pane of glass. I like to enable that. So let's say link all vCenters and then let's get that to work. Once the linking is complete, we will now go ahead and test for inter SDDC connectivity. So now you can see that we have our vCenters linked together. These are the SDDCs we put within the SDDC group within the US East region. Let's log on to one of the vCenters. This is the demo SDDC1 vCenter. So let me log on and let's see what happens now. When we log on, we can now see that we have two vCenters here. Just like linked mode, you can see that we manage both from a single pane of glass. If we scroll down, you would see that this is my SDDC2, and then the one at the top is my SDDC1. So that is how this works together. Once we do this, we are ready to have inter SDDC connectivity. So we can test the connectivity between the two SDDCs. Let me open my console for the first SDDC here. And I was running some tests here. So bear with me on the screen. And let me also open the console for the second virtual machine on the second SDDC. I have some ping tests going on here, but now what I'm going to do is that from SDDC1, I'm going to ping SDDC2, the VM there, and the IP is 10.7.108.2. This is the IP. We're going to ping that to see whether the connectivity is working. And you can see that we have response. So one direction is working. Let's confirm the other way around. If we come to our SDDC in the other availability zone within the same region, we can also ping the SDDC1 and the VM IP is 7.107.2, and we can see that we are having response. So you can see from here that inter SDDC communication is working. We can put more SDDCs into the SDDC group and they will be able to communicate with one another. So this is one simple way of scaling your network connectivity between SDDCs. You can also attach VPCs and let this SDDCs communicate with the VPC as well. But of course, we are not covering that in this discussion. So we have verified this. One call out is that to let this connectivity work, you have to go into each of your SDDC to create the firewall rules to allow this connectivity to happen. In my case, if you come to networking and security, it's loading, and if you go to gateway firewall on the compute gateway, you can see that I have created rules for inter SDDC traffic. Now this console is taking a while to load, so let's get it to load. So this is it. You can see the inter SDDC outbound and inbound, and I have created my rules. And remember that these rules must be applied on the Direct Connect interface. So we do have the interfaces here, which is VPC interface. That is if you want to talk to a VPC, internet if you want to go to the internet, and VPN if you want to go through VPN. So use the Direct Connect interface if you want to enable this. Now, if we want to talk to on-premises, we do the same thing. We would also use the Direct Connect interface or a VPN tunnel as well, depending on what connectivity model being used. So don't forget this is necessary. The firewall rules are important. So now that we have seen how to configure the connectivity between the two SDDCs, how do we get it to now talk to our on-premises environment? Because if we go to our on-premises vCenter here, which is this test on-site VM, if we try to ping any of the virtual machines that we have on the SDDC, the traffic is not going to go through. And this is because we have no connectivity. Let's try to ping the VM in SDDC1, and you will see that the traffic is going nowhere. How do we get it to work? This is where we need to now associate the Transit Connect we have created to our Direct Connect gateway to enable this connectivity. If you come to our Direct Connect gateway associations, you can see I have one transit gateway associated with this. This is for something else. But now we are going to associate our Transit Connect to this Direct Connect gateway to enable that connectivity. Take note that as we enable that, this ping will start working once everything is configured. To do that, we go to our SDDC console and we go to our SDDC groups. And in the SDDC groups, dig into that and go to the Direct Connect tab, right? And from the Direct Connect tab, you have to add the account that is holding your Direct Connect gateway, right? That's account of you, the customer. So click add account. And from here, you need your Direct Connect gateway ID, which is the one we have here, this long one. So we select that and we paste that here. Make sure that there are no spaces at all. And then who is the gateway owner? That is the account ID. That's what they're looking for. So copy your AWS account ID, come back to the console, and then paste it here. Then here it is automatically populated telling us we have a Transit Connect in this region, which is US East. And here we need to type the prefixes from these SDDCs that we want to send over the Direct Connect gateway towards on-premises. This is what we want to advertise. So we just want to advertise the prefixes for SDDC1, which is 10.7.107.0/24. That is the range. And then we want to also do the same for SDDC2, which is 10.7.108.0/24. These are the network ranges that we want to advertise. So after we do this, you just need to also remember that there are some limitations as to the amount of networks you can advertise. You can advertise up to 20 prefixes over a Direct Connect gateway towards on-premises. So if you have a lot of networks, we encourage the use of route summarizations to make this easy. So click on Add, and the very moment you click Add, the initiating process begins. You can see from here that it says requested. What that means is that this account managed by VMware that holds your SDDC has sent a request to your AWS account. And if you come here into your Direct Connect gateway, you can now see that there is a third tab here that says Association Proposals. So we are asking you that do you want to accept this attachment that is coming from the SDDC or not? You can see the proposal ID. You can also see the Transit Connect ID here. You can confirm that from your SDDC console. You can come here to support and you can see that. You can make sure it's all correct, and you can see your account ID and the networks you are allowing or advertising. So if you accept it, just select this and then say accept, and verify if you're happy with all these prefixes and then say accept proposal. Once accepted, the attachment process will begin. If you do that, that tab will vanish if everything is correct. Now click on the Gateway Associations and you can see that we are now beginning to associate our Transit Connect to the Direct Connect Gateway, and that would allow us to get the routes that we are advertising over the Transit Virtual Interface. Now at this point, I must say that this process can take a while. If we come back to our SDDC console, this process can take anywhere between 15 to 20 minutes for this operation to complete. So if you're actually following along using the lab guide, either in a test environment or even, in a production environment, this will be a good time to get a cup of coffee to wait until the state changes to connected. Once it's connected, we are going to go back to our on-site virtual machine to see whether we are able to ping. Now you can see that our ping is not working, but once that is done, the ping will start and we would confirm the connectivity. So let's wait for this operation to complete. In the meantime, as we wait, I would like to also show you something. If you come here to click on the routing tab, you would be able to see all the routes that are exchanged between SDDCs that are attached to the VMware Transit Connect. So you can see routes from SDDC 1 and you can see routes from SDDC 2, all of it showing up here. When we have the Direct Connect gateway associated, we would also see those routes here as well. So you have a granular view of the routes you're sending between SDDCs and from on-premises as well. So actually, if we actually go to the AWS console, we can see that we have our VMware Transit Connect actually associated successfully to our Direct Connect gateway, right? But sometimes the operation can take a little bit longer for it to happen in the SDDC console. So when you see that, still please be patient and wait until this state changes to connected. And at this point, we can see that we have it connected. The state says connected. And if we expand into this, we can see that we have our attachment here. We have the allowed prefixes here as well. And it could take a few minutes before this routing becomes populated. And actually, it's even populated already. You can see the DGW stands for Direct Connect Gateway. And we can see all the routes coming from our Transit Virtual Interface through this Direct Connect Gateway. And it is coming into the Transit Connect, and it can go to each of our SDDCs within the SDDC group. Now, if we go to our on-premises VM, you can now see that it is already pinging, right? We can now communicate from on-premises to SDDC-A. Now, let's try to ping to our second SDDC, and the range for that is 10.7.108.2. And you can also see we are getting response from there as well. So we are now able to ping in a scalable fashion to many SDDCs within an SDDC group from on-premises in a hybrid model. You see how Transit Connect simplifies this connectivity for us. But now you may be thinking, well, is this traffic path not going through the private virtual interface that we configured at first? Actually, no, it is not, because let's go back to our SDDC. As we spoke about in SDDC 1, the private virtual interface terminates on a single SDDC and it terminates on a virtual private gateway. And if we come here to the Direct Connect, what I have done is that I have disabled the BGP. So this path is no longer active just for the purpose of this demo so that you can see that this connectivity here is going over the Transit Virtual Interface. If you have a scenario where you have both interfaces, the Transit Virtual Interface path would always take priority over the private virtual interface. So that is something to take note of. But now that we have done this SDDC grouping within the same region using more than one SDDC, what if you have another SDDC that is located in a different region, perhaps in another country where you are running vSphere workloads, and you still want to connect all of these to your on-premises environment? How do we also do that? Well, I'm going to go ahead and show you how to also do that leveraging this. And let's move on to see how we can do that. We can now come back to our SDDC console and I will show you that. From the SDDC console, we have to go back to our SDDC groups. And now we're going to really create a global network connectivity here. I have another SDDC that is located in the EU region, specifically in London. And that is also running vSphere and my vSphere workloads. And I'm now going to also add that to this SDDC group. So we are essentially extending the boundaries of this SDDC group to Europe to allow for connectivity. So let's go ahead and I'll show you that. It's quite straightforward. If you go into your SDDC group like you saw, just say add SDDCs. And here you would see the SDDC we have available, which is this demo SDDC3. And you can see that that is located in the EU London region. So we just have to select it and then we say add SDDCs. And once this operation begins, what is happening in the background now is that we are creating a new VMware Transit Connect in the London region in Europe. And then once that Transit Connect is ready, we will then attach this demo SDDC3 to that Transit Connect. And then after we do that, we would then create a peering connection between the Transit Connect in the EU London region to the one we have in the US East region to allow for connectivity. Again, we have to wait for this to say connected because currently it is pending. To verify a few things, we would try to send traffic from our on-premises environment here to London. And in London, the IP address for my virtual machine there is 10.7.109.2. And if I ping this, you can see that I'm not sending traffic anywhere at all. Actually, if we come to the first SDDC, which is this SDDC1, and we try to also ping that same virtual machine, we are not able to reach it because we don't have connectivity. You can see that it's not working. If we go to SDDC2 and we try to do the same thing, you would see that that is also not working. And this is because the connectivity is not there. But once this operation completes and the status says connected, first of all, we are going to get the inter-SDDC connectivity. And then after that, we will go ahead to also show how we can demonstrate the hybrid connectivity from this SDDC group globally to our on-premises environment over Direct Connect using Transit Virtual Interface. So let's wait for this operation to complete. we can now see that we have it at the connector stage. So what that means is that the provisioning of the Transit Connect in the EU region is done. We've associated or attached this SDDC to that, and we've created a peering connection. If you come to the support tab, as I showed previously, you can now see two Transit Connects, one here in US East and then one here in the EU region in London. So that is ready. We are now ready to do the inter SDDC test between these three SDDCs. That being said, there is one more thing I can quickly do. If we come to the vCenter linking, I can also now link this vCenter to it, and you can see that it's actually in progress. So once that is in progress and it's completed, what that means is that if I log on into any of the vCenters, I should be able to see three vCenters of each of the SDDCs, and I can manage all of them from a single pane of glass. So let's wait for this to say linked, and then we can go ahead to do the inter SDDC test and then do the on-premises test as well. You can now see that we have it linked. So now let me just re-log into one of the vCenters. If we successfully log in, you're going to see three vCenters here. And there we go, right? You can see that I have my first SDDC and the VM here in this vCenter. If we expand the second one here, this vCenter here, this is the one in Europe. We can see that here, and this is the other second SDDC and its vCenter in US East. So we can manage everything from the same pane of glass. So what we are now going to do is that from SDDC1 here, we're going to our first VM and we're going to try to ping the VM we have in the London region, and this is the IP 10.7.109.2, and you can see we are receiving the ping traffic, and you can see we have the latency here to be stable. This is quite far away, so we have 70.5 milliseconds on the average. If we go to SDDC2 and we want to ping the one in the UK, again you can see that we have the traffic also flowing, and that is also going all the way to United Kingdom. We can communicate with our workloads that way. Now, let's go to the UK one as well. If we go into the vCenter, this is a EU virtual machine. And let's go on to this one. And let's try to also ping from that place to US East 1. So US East 1, the IP we have, one of the SDDCs is 10.7.108.2. When we ping that, we can see that we are also getting a response. If we cancel that, let's try to ping the other SDDC, which is 107.2. With the virtual machine in there, you can see that we are also getting response. So inter SDDC connectivity is done. Everything is working correctly. Now, we showed you, or I showed you, how you can ping from on-premises to the two SDDCs in US East, right? That is working. But let's see if we can ping between EU and our on-premises environment. And the on-premises environment is 10.3.10.2, and you can see that I'm not able to send traffic anywhere. If I come to my on-site virtual machine, I'm not also able to send any traffic. And we know why. This is because our Direct Connect gateway doesn't know about this new Transit Connect that we've created in the London region. So we would have to associate that to our existing Direct Connect gateway to be able to allow this traffic flow to work. So let's do that. Just like you saw, we begin from here, we go into our SDDC group, and we go to the Direct Connect tab. And if we go to the Direct Connect tab here, we are just going to say add. We would expand this one here actually because it's the same Direct Connect gateway we are using. So we just have to say add location, and from here it tells us that we have another Transit Connect in UK, and we now need to specify the route in UK that we want to advertise to our on-premises over this Direct Connect gateway. So once we specify this route, we just have to say add. And the same thing happens. You see, it says requested. A request has been sent to our AWS account where we have our Direct Connect gateway. So we go to the AWS console at this time, and you can see that we have this association proposals tab again. You can find this within the Direct Connect gateway. So now we can see the details about this proposal, and we just have to select it, accept, confirm these routes here, and say accept proposal. And then once everything is okay, this tab is going to vanish very soon when the process begins. And when this tab is gone, just like you just saw, we can now go to the gateway associations, and you can see from here that we are now associating the Transit Connect we have all the way in the EU region to the Direct Connect gateway. Once that association is complete, we will be able to send traffic over our Transit virtual interface towards on-premises, and all the SDDCs would also get the routes we are sending over the Transit virtual interface. So you see how Transit virtual interfaces with the VMware Transit Connect can allow us to have a global network connectivity for vSphere that runs on the AWS infrastructure, which is VMware Cloud on AWS. Now, this operation happening here can take a long time. We've seen it going up to 20 minutes for this operation to complete. So if you're really following along from the lab guide that you have, or you're trying to do this alongside, this will be the time to take some cup of coffee, get it, take some rest, wait for this to say associated. Usually we see this saying associated first in the AWS Management Console, then the next place it gets associated will be here, and then it will say connected, and then we'll be good to go. So let's wait for it to say connected. We can now see that it is connected, which means we are good to go. Now, if you click here on the AWS Management Console, you can also confirm that we have successfully associated the Transit Connect in the London region to our Direct Connect gateway. So from the SDDC console, if we click on the Routing tab, we will be able to see all the routes as well as what is in the London region and what we have in East Virginia. You would see what also comes via the Direct Connect gateway as well as what is inter SDDC. So now let's validate our test. So if we come to our on-premises test VM and we want to ping the VM in the EU region, now you can see that we are having a response time, right? It's returning response. If we go to our EU virtual machine and we also try to ping the on-premises virtual machine, you can see that we also have a response time. So what have we done? We have configured a global connectivity of our VMware Cloud on AWS environment in a hybrid model to our on-premises environment using Direct Connect, Transit Virtual Interface, VMware Transit Connect, and Direct Connect Gateway. How wonderful is that? And if you're wondering how the Direct Connect Gateway works, that is a global construct. It is not tied to a specific region, and that allows you to extend the capabilities of existing Direct Connect environments to elsewhere in other regions, even to other countries, just like we have done in this demonstration. So I hope this demonstration has been informative for you, and now let's go back to our discussion. So thank you for taking time to watch that demonstration. You have also learned how to configure this Transit virtual interface to allow you to configure this hybrid network connectivity models. On the screen are some useful links that you can learn into detail. So scan these QR codes. It will take you to some of our blog posts on how we recommend how to do this with resiliency in mind, because resiliency is also important. So take some time to scan out these codes and visit these sites and bookmark them. And coupled with the lab guide you have, you can perhaps work by yourself and configure this in a production setting within your own business. So I want to take this opportunity to thank all of you for taking a lot of time out of your day to join us here today in this session.